Alright, sorry about the first part 1 video. I didn't realize those were all obliques. And so what we're going to do is we're going to do question number 2 and number 4 from your homework pack sheet. And then I'll leave you everything else to do. So on the first one, since the numerators and the denominator don't need to cancel anything out, we're going to just look at our vertical asymptote. Your vertical asymptote is due to the value on the bottom. And if you set it equal to 0, you would have x equal to -2, but we can't have that. So that's why it's an asymptote. If I plug -2 in, -2 plus 2 is 0. So that's why it's a vertical asymptote. I'm going to go pop that down right here on the graph. Okay. And then we're going to work on our horizontal asymptotes. Horizontal asymptote is based on your numerator denominator powers. So I have x over x. Since those are the same power, the coefficients are 1 over 1, which means I have an asymptote at y equals 1. So I'm going to come here and I'm going to draw that one in. Now, the fancy thing about these graphs is we require you to write down any points of discontinuity, which are your holes, vertical asymptotes, x-intercepts, horizontal asymptotes, and domain of each. I think the holes was supposed to be y-intercepts, but I don't recall. So we're just going to let it be, and we're just going to go find points. So what happens is we're going to go type this in our calculator. Casio's, as I've said, you got to remember how to type things in your calculator to get to your graphs and to your tables. You're going to use parentheses. I am not going to use the fraction buttons because most calculators don't have access to those. If you want to use the fraction button, you can. You just be careful because your answers may pop up as fractions. And so I'm going to go graph. And so as you can see, I have asymptotes. And what I'm going to do is I'm going to go to my table. And I see an error at -2, which is awesome. So the first thing is you have to have your x-intercepts and your y-intercepts. So your x-intercepts are where your graph hit y equals 0, which as you go through here, we have one there. So I have a point at 4, 0. So 4 zeros here. Okay. And if you want to go find the other one that matches that, it'll be a little bit here. We'll talk that in a second. And then I have 0, -2. So 0, -2 is my other intercept. Okay. So I like to make a table, and I'll explain why. It makes it a lot easier. And then I'm just going to find one other point that I like, and I'm going to use 1, -1. So 1, -1. Okay, so I have 0, -2, and there's going to be a match to it. I have 1, -1, and then I have 4, 0. Okay, so what happens is these are mirrored across. So if I go over 2 and down 3, if I come over here, I'm going to go over 2, up 3. And that point will match. If I go over 3 down 2, come back over here, over 3 up 2, and this was over 6 down 1. If I go over 6, I would go up 1. Now, you don't have to do that. You can find any other points you like on the other side if you look here on the graph. Okay? But I'm one who does one by mimicking or mirroring because it's a reflection. So if I count over 6 and 1, so 6 and 1 would be here. So this mirrors with -8 and +2. If I go over 3 up 2, or over 2 up 3, that puts me at -4 and +4. And like I said, if I go over 3 up 2, that puts me there at -5 and +3. They go in pairs. That's the mirrors of each other. You can find whatever points you want as long as you have your x-intercepts and your y-intercepts. So your x-axis points where you have y equal to 0 and your y-axis points where your x is 0. And then you just sketch it. So bring it up and graph. And graph, don't go across that asymptote. That one's really close, but honestly, not going to panic. All right. Domain and range. Domain is all real numbers. X cannot equal -2. And your range, because it's not a split range, is all real numbers. And Y cannot equal 1. So the next question we're going to do on here is going to be question number 4. Question number 4 is pretty easy as well. We'll talk about factoring and things like that. So the first thing we're going to do is we are going to rewrite the problem in factor. So factors of -2 is x minus 2 and x minus 1. I want a positive 1, so it's a positive 2. Factors of 6 that give me a 1 are going to be an x plus 3 and an x minus 2. Those 2's are different, so if you had the wrong signs, you would cancel things out that shouldn't cancel out. And then we're going to look at our vertical asymptotes. So in the denominator, my vertical asymptotes come from x equal to -2 and x equals 1. So I have one here at -2 and a value at 1. Okay. Horizontal asymptotes. Horizontal asymptotes come from the original problem before we start anything. Since nothing canceled out, I have x squared over x squared. So those values are going to be 1 divided by 1. So I have an asymptote at y equals 1. I'll draw that in here. While I'm drawing that in there, I'm going to go over and I'm going to plot some points in my calculator. So I'm going to type the original problem. X squared plus x minus 6 divided by x squared plus x minus 2. Go to my table, go to my graph, and you'll see my graph is here. I'm going to zoom in really well. So I'm going to go zoom 6 if I can't see things. And so this is what I have. So as you can see, there's a split range again. So I'm going to get my purple pen. I'm going to make a table. Okay. And the first thing I'm going to do is I'm going to go calculate that minimum in the middle. So I'm going to go second calc, minimum. And I'm going to make sure I go on the left side of it. Don't cross over. Make sure you stay on that top part, because if you go too far, you'll see your cursor move. And I'm going to stay enter. Enter. So I have it at -0.5 and 2.7 repeating. And this is a min. All right. And what we're going to do again is we are then going to calculate out the y-intercept. So I'm going to go second table. I'm going to find where x is 0. And so I have one at 0. Whoops. And then the other side of that is -1, 3. So 0, 3. So I'm going to go plot this. So 0, 3 is here. And the other points are right there. And right in the middle, I'm going to put a little dot. And the sketchies. And then this is the really cool thing about the next part, is you just got to find one other point on each side, which one of these happens to be the x-intercept. They actually both are. So, -3, whoops, wrong side, Pomeroy. -3 goes with 0. So -3, 0 goes right there. Because you got to find the x-intercepts. And then if you look here, 2, 0. So if those were not your x-intercepts, you have to find the x-intercepts. Don't ask me why. They want you to. Not a big deal. It's more so I don't know. But what you're going to do is you're going to find points on the other half of the graph. So when you do this, you're just going to draw these down. And come up. They don't have to be perfect. Those are the 5 points you need to have. And then you're done. After that, we go to domain. All real numbers. X cannot equal -2, nor can it equal 1. Range. Once again, this is a split range. So with a split range, what we're going to do is we are going to say y and my asymptote of 1. And we're going to ask us where those two curves are. They are below it, so it's going to be less than 1. And then what we're going to do is we're going to go look at that minimum. And we're going to go y is greater than or equal to 2.7 repeating.